Okay. The next question you can see here. The magnetic moment of Ni 2 minus ion is found to be 0. Means it means that for this complex ion, the magnetic moment is 0. Means no unpaired electrons. Then the metal of the complex ion is, he is asking the hybridization of that metal, that is called as nickel, which is present here, and in bracket he is giving X is equal to monodentate anionic ligand, means it is having a -1 charge. So if they give the complex ion and they ask the hybridization, what is the technique you have to follow is, see, first you should go for the compound NiX4 2 minus. You should find out the oxidation state. X minus 4 is equal to -2. X is equal to +2. Means the oxidation state of nickel is Ni2 plus. We know the atomic number of Ni is 28, 3D8, 4s2. So if you see the 3D8, 4s2, you can understand the configuration. And the configuration of Ni2 plus is, remove the 2 electrons, it becomes 3D8. And when it becomes 3D8, you should draw the orbital picture which contains 5 orbitals. 8 electron means 1, 2, 3, 4, 5, 6, 7, 8. You are seeing the 2d electrons which are unpaired, but we know that X is a weak field ligand. Weak field ligand means we cannot combine inside. Therefore, these 2 orbitals are involved, and next one is S, and next one is 3 orbitals, like that. Okay. If it is a strong field ligand, they will combine here. So if it is a weak orbital, means 2 d orbitals are involved. Therefore, the answer D is correct. That is D2, 1 S and 3 p orbital. Therefore, fourth option is correct. And in next exam, whatever if they ask the question like this, FeCl6 minus 4, again do the same process. Calculate the charge of iron. It is a strong field ligand. Pair the electrons. You will understand the hybridization. Okay. Next question. A complex compound in which the oxidation number of metal is 0. He has given 4 complex compounds. You have to identify which atom or metal has a 0 oxidation state. So for your sake, I will solve all the 4 questions. You can identify easily. 4 plus x minus 6 is equal to 0. X is equal to +2. Directly I have solved. If you are perfect in first redox reaction chapter, easily you can calculate. Here 3 plus x minus 6 is equal to 0, x is equal to +3. And here x plus 4 into 0 is equal to 0, x is equal to 0. And here it should be Pt, that is platinum. X plus 4 into 0 minus 2 is equal to 0, x is equal to +2. So you got the 4 answers here. He asked a complex compound in which the metal element charge is 0. So you can identify easily the answer is NiCO4. The name of the compound is nickel tetracarbonyl. Hence the answer is 0. Okay. Next question. Ammonia will not form complex ions with. So already you know ammonia is a Lewis base which contain a lone pair of electrons. It will not form a complex ions with, he is asking. First one is silver ion, second one is cadmium 2 plus, third one is copper 2 plus, and fourth one is Pb2 plus. So directly you can tell the answer, that is called as Pb2 plus. Why? If they ask Ag contain d electrons, Cd contain d electrons, Cu contain d electrons, but P last P plus 2 lead contains P block element. And the element which contain a P electrons will not form the coordination compound or complex ion. Hence the answer 4 is correct. Pb2 plus. Next question. K3Al C2O4 thrice is called. He has given one complex compound. He is asking the name of that compound. So what is the name of that compound? You should understand. First option, potassium alumino oxalate, potassium trioxalato aluminate, potassium aluminium 3-oxalate, potassium trioxalato aluminate. First you remove the option A. Why means here he has not given the oxidation state in the bracket. So now I left with the three options, then go for the rules. Here only one ligand is there. Your name should start with the potassium, then tri. See the option potassium tri, potassium aluminium, potassium tri. After this tri is not there, remove this option. I left with only two things, potassium tri, potassium tri. Next what you have to find out? Oxalato. Whether it is present, oxalato is there, oxalato is there. Next aluminate, aluminate. Both are correct. Now only difference is charge, 3 and 6. Find the charge for this compound, you will get the answer here. So I will find the charge for this one, 3 plus X. You know that C2O4 is a bidentate ligand. It contains a -2 charge. Therefore, -6 is equal to 0. X plus 3 is equal to 0. Therefore, X is equal to X minus 3 is equal to 0. X is equal to 3. Here you are seeing 3. Here you are seeing 6. So directly you will get the answer. Which will be the option? Option B is the correct answer. So like this in all the aspects, if you check easily, you can get the answer for this IUPAC thing. Okay. Next question. Which of the following complexes will consume more equivalent aqueous solution of AgNO3? All of you know in the complex compounds, if it is a ionization isomer, when they dissolve in any solution, they will form the PPT. Because AgNO3 is the best precipitating agent. Okay, let us see now. Here AgNO3 will react with only the ion which is present outside the bracket. Here Na is present outside the bracket, it may be the answer. Here Cl2 is present, it may be the answer. Here Cl3 is present, it may be the answer. Here Na is present, it may be the answer. Means by that concept we cannot identify the answer. Next we go for other things. More equivalent he is asking. More means number you calculate. It is 3, it is 2, it is 3, it is 2. 3 is larger number, so answer may be A or B, A or C. Remove B and D from the option. Now in this matter, again what you have to check means, you have to understand. AgNO3, Ag plus is main, positive charge. Here Na is positive charge, Cl is negative charge. Positive always attract with the negative. So it is having negative. So this will be the wrong answer. Answer is Cl. So in three aspects you have to choose. What happens here? If you take this compound and react with the 3 moles of AgNO3, you will get 3 moles of AgCl precipitate. Hence the answer for this one is third one. Okay, next. Which among the following will be named as dibromido-bis-ethylene diamine chromium 3 bromide? So again same concept you have to use. What he is asking, let's see. Dibromido. Identify where dibromido is there. Tribromido. Dibromido. Okay, good. See here, dibromido is asking. This option is wrong, first only. Here di, it may be the answer. Here tetra is there, remove that. Dibromido is there. So answer may be between B and D. Next, bis. Bis means what? En 3 times, En 2 times, En 1 time. So here only we will get the answer. We are fighting for B and D. Here En is only 1, remove that, answer we will get. But this is not actual technique. Sometimes En will be 2 times. That time what you have to see? Again see, chromium. Where chromium is present, you have to see, all contains chromium. This is the main factor, that is called as 3. So see all the charges, I will find only for B and D. X minus 0, minus 2, minus 1 is equal to 0, X is equal to plus 3. and here x minus 0, minus 2, minus 1 is equal to 0, x is equal to plus 3. So here also 3 and 3 is there, but difference is here bromide, here also bromide. So what will be the factor, key factor for this one is En is 1, En is 2. Therefore, the correct answer is dibromido bis diethylene diamine chromium 3 bromide. Hence the answer is B. The magnetic moment spin only of NiCl4 2 minus is. In the previous class, I solved many problems with respect to magnetic moment, but in previous exam question paper they have asked different times. So again, I am solving. Who have not understood last class, they can understand about this one. See, magnetic moment of NiCl4 minus 2. First work you have to do is find the charge of central metal atom. So X already this answer will be displayed because it is from a previous question paper. Blue color line you are seeing. Now all the questions will be displaying the answer also. X minus 4 is equal to minus 2. X is equal to plus 2. Therefore, the charge of nickel is Ni2 plus 3d8 4s2. Remove this electron, D will be there. 3d8 means 1, 2, 3, 4, 5, 6, 7, 8. We are having n is equal to 2 unpaired electrons. We have the formula mu is equal to root of n into n plus 2. Substitute that, it becomes 2 plus 2 is equal to root of 2 into 4 is equal to root of 8 is equal to the answer is 2.82 dm. Okay, so this is the method for any complex ion. This is just the model I am showing you. Okay, next question. Which of the following pairs represent linkage isomerism? You should know the definition first, then the answer will be easy for you. What is the definition of linkage isomer? The isomerism in which there are 2 or 3 donor atoms which will donate the lone pair of electrons either by this atom or either by this atom. So you have to identify in which compounds 2 donor atoms are present. Here, N is the donor, S is the donor, S is the donor, N is the donor. Here, only NO3 is N donor, and here S is the donor, and here N is the donor, N is the donor, here N and N. So if you see all the examples, in all the 3 options, only one donor atom is there, but here two donor atom is there. SCN means thiocyane. NCS means isothiocyane. If the nitrogen donates the electron, it is one time. If S donates the electron, it is one time. The isomers in which both donor atoms donate the atom, hence the answer is A for this question. Next question. Which of the following octahedral complexes of cobalt atomic number 27 will be the magnitude of delta naught be the highest? You know that there are tetrahedral and octahedral 2 complexes are there. Okay, so you should know that in a tetrahedral complex delta naught will be different, and in octahedral complex delta naught will be different, and this is purely based on the strong and weak field ligand. If you see all the 4 options, Cn is a strong ligand, C2O4 is a weak ligand, H2O comes in the middle, NS3 is a weak ligand. So directly you can identify the answer. The complex in which the strong field ligand is there, it will undergo octahedral complex. The answer is first one, that is called as a A. Next question. Nickel Z is equal to 28 combines with the uni-negative monodentate ligand X minus to form a paramagnetic complex. The number of unpaired electrons in the nickel and geometry of the complex ions are respectively. So he asked, what he is asking, let's see. He wants the number of unpaired electrons and we want the geometry of the complex ions. In all 4 options, whatever the first word you are seeing, it will be the unpaired electron. Second word you are seeing, it will be the geometry or shape of the ions. Okay. NiX4 2 minus. In a previous problem only I told how many unpaired electrons are there. 3d8 means 2 unpaired electrons. First only you got the answer 1 2 1 2. So 1 1 will be removed. The answer is between this B and T. Now the question is whether it is tetrahedral or square planar. So see here what I will tell you. The shape of the geometry depends upon the interfere of the orbitals. Okay, and here X is the weak field ligand. Due to that, it will not undergo square planar. It will undergo the option that is called as a tetrahedral. Next question. In FeCO5, the Fe-C bond possesses. In coordination compound, you come across one concept that is called as a metal bonding in the carbonyls. Okay, back bonding, pi, sigma, like that. So related to that, we are having the question. You can understand FeCO5, which is called as iron pentacarbonyl. 5 CO groups are attached to that. Now he is asking the question, which bond possesses pi character only, both sigma and pi character, ionic character, sigma character. First remove the waste option that is called as C, because carbonyls will not show the ionic character. Now the confusion is between only sigma, only pi, or both sigma and pi. So here you have to understand there is a bonding between the carbon and Fe is dp bonding. Therefore, it forms the pi bond, and the bonding between C double bond is sigma bond. Hence, the answer for this one is B. Both sigma and pi characters will be formed. Okay. Next question. How many EDTA, long form is given, molecules are required to make an octahedral complexes with Ca plus 2 ion? Means what is the conclusion here? Ca2 plus is a central metal ion. To that you have to surround by EDTA. So the easy question is that if it is a monodentate, 6 are required. If it is bidentate, 3 are required. If it is tridentate, 2 are required. Tetra cannot be possible, penta cannot be possible. If it is hexadentate, only 1 is required. Now you should understand whether it is a mono, di, tri or hexadentate ligand. All of you know that it is a hexadentate ligand because ethylene diamide means 2 donor atoms. Tetra means 4 acetate ions. So how many donor atoms are there? They are having 6 donor atoms. Therefore, already 6 are present in this one. Sufficiently, we can use this one only 1. Therefore, the answer for this question is 1. If it was a cyanide, my answer was 6, this option. If I take C2O4 minus 2, my answer was 3. If I take the tridentate ligand, my answer was 2. Therefore, the answer is 1. Okay, next. The coordination number of central metal atom in a complex is determined by. So what is asking? Coordination number. Already you know coordination number means which will donate the electron. Central metal atom in a complex is determined by which factor? Number of ligands surrounded by sigma bonds, number of anionic ligands bonded to metal ion, number of ligands around the metal ion by sigma and pi bonds, number of ligands around the metal ion by pi bonds. First remove the waste option. This is waste because pi bonds are not formed. Here also remove this option because pi word is in. Remove this one. Now in this pi is not there, in this pi is not there. Answer may be between these two. Why it is wrong? Number of only anionic ligands is given. But according to our concept, what is there? One should be anionic ligand and another should be lone pair electron atoms. Therefore, the number of ligands around the metal is bonded by sigma strong bond. The answer is first one, that is called as A option. Next question. Coordination compound have great importance in biological system. This question is related to application of coordination compound. In this context, which of the following statement is wrong? He has given four options. In that, you have to identify the wrong statement which is related to biochemistry. Okay. I will go from the bottom. Hemoglobin, all of you know, which is present in the blood, is the red pigment of blood and contains iron. This is correct option. Okay. Cyanocobalamin, which is called as a complex vitamin B12 and contains a cobalt. This statement is also correct. Carboxypeptidase A is an enzyme and contains zinc. This also we know it is correct option. Chlorophylls are green pigment. Up to this it is correct. Up to plants it is correct. And contains calcium. This is wrong. Because chlorophyll contains what? It is called as magnesium ion. He asked incorrect statement. These are three correct statements. This one is false. Hence the answer for this question is A. Okay. What should be present? It should contain the magnesium. Next question. The correct order of magnetic moments, spin only values in Bohr magneton among the compounds is. Again, I am solving this is fifth question which is related to spin magnetic moment. He helped you by giving the atomic numbers. So again go for the formula. First find out all the three answers, directly will get this one. Okay. So directly I will solve. Don't see the option. Only go for the compounds. First one is MnCl4 2 minus. Second one is FeCl6 4 minus, and third one is CoCl4 2 minus. Here you solve the answers, then go for the option. X minus 4 is equal to minus 2. Oxidation state is plus 2. X minus 6 is equal to minus 4. Oxidation state is plus 2. X minus 4 is equal to minus 2. Oxidation state is plus 2. All are having the oxidation state same. Now the work is not over. Mn is plus 2, Fe is plus 2 and Co is plus 2. Go for the atomic number and configuration. 3d5 4s2, 3d6 4s2, 3d7 4s2. I am writing the atomic number of metals. Remove 2. It left with n is equal to 5. Remove 2. It left with n is equal to 4. Remove 2. It left with n is equal to 3. Here you got the answer. N is equal to 5, n is equal to 4, n is equal to 3. This is high, this is medium, this is low. Go for this one. Give this number 1, give this number 2, give this number 3. He is asking in a greater order. Where MnCl4 is first here. In first option here it is. In last option it is here. Remove these two options. Second place it should go for Fe. Here CO is there, here Fe is there. You have to identify. Yes, so answer should be D because that printing mistake it is. First one is Mn, that is plus, n is equal to 5. Then it should come n is equal to 3 and then here n is equal to 4. Therefore, the correct answer for this one is Mn, Fe and greater than CO. I solved a lengthy technique. Directly you can find without solving anything based on the atomic number. How I will tell you, this is 25, this is 26, this is 27. Directly if you write, your answer will be this one. Both techniques I have told, you can identify this one. Next question. CS3MgBr is an organometallic compound due to. So already you know, this compound name is methyl magnesium bromide, which is also called as Grignard reagent in organic chemistry. He is asking organometallic compound is there. Organo means carbon content, metal means transition element. He has given some answers here. Mg, S block element, Br, P block element, answer wrong. C, organic compound, Mg, S block element, answer is correct. C, organic compound, Br, P block element, answer is wrong. C, organic compound, H, D, S block element, answer is wrong. Therefore, the right answer is C, Mg bond. Organic compound and metal compound, it becomes an organometallic compound. Okay. Next question. The most stable ion is. When he asks the question like this, no need to see the answer. Only one thing you have to remember, which contain a strong field ligand, it will be more stable, which will be weak field ligand, it is a less stable. OH, weak field. Cl, weak field. Cl, strong field. H2O, neutral. Therefore, the answer is C. Strong field ligand mode is the stable ion. The types of isomerism present in nitropentamine chromium 3 chloride is. It is asked in one exam. He is asking the isomerism. So first you should know to write the formula of that. Nitro NO2 pentamine 5 NH3. 3. You should find later. Chromium is the metal. Chloride is outside. So first write like this. Check whether the oxidation state is correct or no. X plus 5 into 0 plus 1 minus 2 is equal to, minus 1 minus 2 is equal to 0. X minus 3 is equal to 0. X is equal to plus 3. So I got this one. But now it is not an answer. He is asking the types of isomerism. Optical means mirror images. Linkage means two donor atoms. Ionization means ions going outside. Polymerization is a wrong option. So answer may be between the three. Here you can find N is the donor, N is the donor, but not the same compound. Linkage is cancelled. Next, optical and ionization. Here it is 5, it is 1. It cannot find the mirror images. Option is wrong. Obviously, the answer is ionization. But how it is ionization means Cl is present outside. Remove this Cl outside, it becomes Cl minus, and this becomes plus. Therefore, the correct answer for this question is ionization. Okay. Next question. The value of the spin-only magnetic moment for the following configurations is 2.84 pm. The correct one is C. Again, same concept, but this time he only given the value. You should identify this one question. Okay. So how to do that? Let's see. 2.84 bm means N is equal to how many unpaired electrons? You have to understand. For 2.84 bm, N is equal to 2. So in all the four options where N is equal to 2, that will be the correct answer. D4. 1. Strong field we told. So they are paired 0. Answer is wrong. D4 in weak field ligand. 1, 2, 3, 4. Weak field means they will not pair up 4 unpaired electrons. D3 in weak as well as in strong fields. Okay. So here D3 means 3 orbitals. Weak as well as strong he is asking. So 1, 2, 3. It is weak field ligand. If it is strong, it will become 1, 2, 3 like that. And last one is a D5 in strong field ligand. So D5 means here you can see 1, 2, 3, 4, 5. So by seeing this you can understand which one will be the correct answer. So here I will come again. So here 1 will be paired and this electron will be removed here. We get 2 unpaired electrons and N becomes 2. Therefore the right answer is D3 in weak as well as strong field ligand. Okay. Next question. Which of the following has a square planar geometry? As I already told you, geometry and hybridization depends upon the electrons. You can see here COCl4 2 minus. You can understand CO charge is plus 2, Ni charge is plus 2, the P charge is plus 2, Pt charge is plus 2. CO plus 2, 3D, 7, 4s, 0. It contains 3 unpaired electrons, therefore it cannot be square planar. 3D, 8, 4s, 0. It contains 3 unpaired electrons, it cannot be this one. Fe2 plus 3D6, it contains 4 unpaired electrons, it is having a d hybridization. and Pt plus 2, it contains only the sp3 hybridization. Like for the answer, one for this one is PtCl4 2 minus. Okay, next one. So this is the question which is lengthy, and now we go for this last question for this one. The ionization isomer of CrH2O4 NO2 minus is, again I told you, ionization isomer means what? Ions changing. So here easily you can see here Cl NO2 Cl is there. You can take Cl inside, NO2 outside. Where it does like that, you can observe. Here you can see NO2 and Cl2. Here H2O is there. It is hydrate isomerism, and NO2 Cl. It is correct. It is wrong. It is wrong. The answer for this one is ONO inside, Cl outside. NO2 inside, Cl outside. The example for this one is ionization or isomerism. So these were the question based on the coordination compounds chapter. In our next session, we'll start with the another chapter. Thank you. Okay.